Hi guys, good morning. Can you hear me? Yeah. So let us start session. Let us start session. Yeah, one second. Some guys are facing issue in joining. Yeah. So previous class, all the basics completed. Today topic is Java features. Today topic is Java features. Yes, first one. See. Yes, your class 9:15. Day 2. Yeah, this is Java features, right? Java features. See, let us see all these features. So till now what are discussed, these are all our basics. These are prerequisite to understand Java features. Last 2 days classes. Last 2 days classes topic is a prerequisite to understand Java features. Now let us start. First one, independent platform. Java is an independent platform. Okay. Yes, Java. Yes. Java is an independent platform. Yes, what does it mean here? Yes, what does it mean? Yes, what does it mean? Java is independent platform. So what does it mean? See, platform means OS, right? Platform means OS. Previously we discussed OS is a platform where we can run all the application softwares. Here platform means operating system. Operating system. Platform means operating system. Platform means operating system. So Java is independent platform means Java program. Yes, Java program. Yes, can run on any OS, on any operating system. That's it. Java is independent platform. Java is an independent platform means Java program can run on any OS. Here platform means operating system. Platform means it's a operating system. Platform means operating system. Java program can run on. Now question is how? Yes, Java made us independent platform. Independent of platform. This is important point. Yes. How Java made us independent platform. So this is today's topic. How Java made us independent platform. Yes. Yes. Java made us independent platform. How Java made us independent platform. Let us answer this. Okay. Yes. How Java made us independent. How Java made us independent platform. Okay. How Java made us independent platform. Okay. How Java made us independent platform. Yes. For this purpose, first of all, you must have the exe file knowledge. Yes, first of all about exe. Let us see about exe file. Yes, about exe file. About exe file. Here some question for you guys. Some question. Here some question for you guys. Exe file. Sorry. Exe file prepared. Exe file prepared on Windows OS. On Windows OS. Okay, exe file prepared on Windows OS. Can I run on Linux OS? This is a question. Yes, anyone, can you answer this? Yes, exe file prepared on Windows OS can I run on Linux OS? So this is a question. Yes, come on, guys. Please try to answer it. Say yes or no. Yes, most of the guys are saying that yes, yes, yes. Yes, most of the guys saying that yes, and Suchita saying that no. Yes, Kalyani saying that no. Here answer exe file prepared Windows OS can I run on Linux OS? Answer is no. No, we can't run. Reason. Reason is yes, exe file is a OS dependent. OS dependent. Exe file is a OS dependent. OS dependent. Now immediately question why exe file is OS dependent? Why exe file is OS dependent? OS dependent. Yes. Reason exe file is OS dependent. So exe file prepared on Windows OS can I run on Linux OS? Yes, Windows based exe file can run on only Windows OS. So we prepared a Linux OS, only Linux OS here. Yes, reason exe file is OS dependent. Why exe file is OS dependent? Immediately question is why exe file is OS dependent? Yes, to answer this, you must have the exe file knowledge. For example, here, for example, C program, exe file prepared on Windows OS. Windows OS. C program exe file prepared on Windows OS, then it contains words. It contains words. Let us see. It contains words. Yes, let me show practically. See. Yes, this is Windows based C language. See here, this is some files like this. Here, this is math.cpp. Math.cpp, right? Yes, backend. Backend of this is C drive, turbo C here, turbo C installed in bin folder. It's available. That math.cpp. So this is math. Okay, 1 second. Yes, let me delete this related names, related files. Now this is math.cpp. So math.cpp. Okay, 1 second. So math.cpp file here. Yes. Saved. File saved. See here CP file 9:32 AM 13.5. 13.5. Okay. So today 13.5. So 13th May 9:30 AM saved. Now let us compile. Compile. See here math.obj file generated. See this math.obj file. Once you compile, generated one object file. Yes, what is this object file? What is this object? Yes, this object file contains binary code for our C program. Binary code for our C program. So this is your C program, right? Your C program, binary code for C program. So binary code for the C program. That object file contains binary code for C program. Next, C. Here there is some library. Here there are some libraries. stdio.h, conv.h. C libraries, right? These libraries also having its own binary. Yeah, these libraries are having its own binary codes. Yes, for this program, binary code is math.obj file. That's it. Now, creating exe file. When you try to run it here, yes, when you try to run it here, once here. Yes, when you try to run it, when you try to run it here, run it. Now it will create exe file. Creating exe file. See that math.exe file created. Math.exe file created. And executing. Yes, first number, second number. Yes, done. That exe file. So what's happening at the time of creation of exe file here? So at the time of creation of exe file, the C compiler taking object file for our program is binary code for C program plus binary code for C library, stdio data cetera file and conv data cetera file, and plus binary code for OS library. By linking all of this, it generates exe file. Okay, so C program exe file. Yes, C program exe file. C program exe file prepared in this way, then it contains binary codes for yes C code for C program plus binary code for C program means that math.obj file plus 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 binary codes binary plus binary code for C library binary code for binary code for C library means binary code for C library means here binary code for C library. Yes, here it's a stdio data cetera file. Yes, coordinator cetera file. These are also having which one binary code. The predefined library. That predefined library also has the binary code. Okay. Plus yes, Windows. Yes, Windows plus Windows OS. Yes, plus binary codes. Binary codes for Windows OS library. Windows OS library. This is an exe. So when exe file, C program exe file prepared in Windows OS here prepared on Windows OS, then it contains binary code for C program, binary code for C library, and binary code for Windows OS library. By linking all of this in generating exe file, library, OS library also linking with your C program exe file. That exe with Windows OS library. See, at the beginning we have discussed about OS concepts. See, this point, 4 points. Every program has to link with OS library before going to start execution. Every program has to link. C program has to link with OS library. Java program, like this, every program has to link with OS library. Of linking only, the execution starts. It has to link compulsory here. Yes, in case of C language, what happens here? In case of C language here, at the time of creation of exe file itself, that OS library links with exe file. So finally, exe file contains a binary code for C program. Yes, binary code for C library. Yes, binary code for OS library, Windows OS library. Yes, let us see one more example. Yes, C program. Yes, another example. Second example. Yes, C file prepared on Linux base. Okay, now you can understand very clear. Linux base. See, on Windows OS, yes, backend happening automatically everything. Exe file creating and all this happening at backend. But Linux, you have to do manually. Linux, yes, compiling program. Next, creation of exe file. Yes, you have to do manually. Now you can understand very clearly. Yes, let us see Linux base. Yes, creation of exe file in Linux base. That exe file contains what? Yes, now, yes, we'll see practically. I'll show practically. The login, demo login. Yeah, this is Linux base. Okay, Linux base. Yes, we are my it's a command is here. This one shows current login user. Demo is a current login user. It's working directory demo. ls is contents. Worry about Linux commands. You guys don't worry about Linux commands. Okay, one second. Yes, Linux command. That is not our topic. Our topic is about exe file. cd mn drop. Yes, cd. Yes, yes, some mn drop directory. Change of directory. Okay. Yes, present working directory mn drop. ls. ls is coordinates, nothing here. Yes, one second. Let me clear this. Yes, all are deleted here. Present working directory mn dot directory in this. Nothing, no files, no directories. Now let us write C program. Gread test.c program. Gread test.c. Test.c. Yes, hash includes stdio.h. Hash include stdio.h. Yes, next white. Yes, main function. Sorry, white main function. Yes, starting ending. Main function starting ending. Yes, here. Yes, int a declared. So next int b. Yes, declared. So int a, int b. Right? Yes, after this next int c declared. Int c, int c. Yes, in this here a is equal to 10, for example. Yes, b is equal to 20. Yes, same example. Addition, subtraction, and multiplication of two numbers. A equal 10, b equal 20. So int c, third variable c. Yes, that c equal to third variable c is equal to yes a plus b. A plus b. Yes. Now printf. Yes. Addition. Addition equal to personal d. Yes, personal d comma c displaying c value. C value. Right. So addition this is right. Next subtraction and multiplication. Yes, subtraction. Yes, subtraction is equal to c. So here c equal to a minus b. C equal to a minus b. Yes, next c equal to a into b. A into b. Next multiplication. It's a multiplication. Multiplication equal to multiplication equal to right. So this is C program. Yes, save. Now let us compile this. Yes, here it's a C ls test.c file compilation. It's a manual compilation. GCC C language compiler. See turbo C. So directly here from the yes alt C compilation alt run. But here it's a everything is manually using command GCC hyphen just it's a compilation. GCC hyphen C means only compilation. GCC is a C language compiler. C language compiler compiling test.c file. Okay, see this. Yes, test.c file. Yes, some error. Yes, stdio data center file. Yes, stdio data center file. Okay, yes. Okay, right. Yes, now let us compile. Okay, let us compile. Yes, GCC ls. The test.o file created. Okay, just I'm explaining about exe file. explaining about exe file. Topic is about exe file. See the exe file, about exe file. C program exe file. Suppose C program is like this C program. C program. Yes, int A equal 10, B equal 20. Yes, C equal to A plus B, addition. C equal to A minus B, subtraction. C equal to N multiplication. Okay, the C program exe. This is C program. C program. Of writing C program, next we should compare it. For comparison, GCC hyphen C test.c 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 compiled ls. After comparison, check it here. Test.to file. What is test.to file? This test.to file contains what binary code for C program. Binary code for C program. Binary code for C program. So binary code for C program. See, binary code for C program means this part. Binary code zero funds for this part. Wide main binary code for C program. Next, one more thing, STD is also having its own binary codes. Okay, fine. Okay, so test.to file created. After creating this one contains binary code for our C program. Next, finally creating exe file. GCC hyphen o yes project exe file. Exe name is project test.to. See, yes, you guys try to understand about exe file. Don't think about C program. Yes, our topic is not C program. Our topic is about exe file. Yes, try to understand about exe file. Don't try to understand about C program. Yes, how C program writing, C program compilation, C program exe. That is not necessary for us. Our topic is not C program. Yes, that is not necessary. Writing C program, compilation, creation of exe file. That is not necessary. That is not necessary for us. That is not our topic here. Okay, just try to understand about exe file. See here after compilation, yes, test.to file created. This test.to file contains binary code for C program. Yes, try to understand this point. Test.to file contains binary code for C program. Okay, now GCC-O. O means object file. Linking object files and creating finally project exe. The project exe file. Yes, created. LS, see that? The project exe file created. Now running that exe file. Yes, running that exe file. See that? Addition, subtraction, multiplication. Okay, 1 second. Yes, next line. We should take to next line. Let me change some program. Slash and take to next line. Slash and taking to next line. Next line. Slash and to take next line. Slash and save and close. Yes. LS. Okay. Yes. Now I'm creating exe file again here. See this. Remove. 1 second. Yes. See this. LS. The test.c program. First compilation. GCC -c test.c. Test.c compiled. After compilation, we got test.to file. This contains binary code for C. Remember this. This is binary code for C program. Okay. Now GCC. Yes, GCC -o some project result ex name is project. This name can be anyone. This name can be anyone. This name can be anyone. Not test.o. Yes, now ls that exe file project exe file created. Just I'm running that project exe file. Yes, output addition, subtraction, multiplication. Yeah, this exe name can be anyone. Yes, let me create one more exe, another name, any name that can be. Suppose this name is from Durga. Yes, ls see that Durga exe file created. So this name can be anyone. So dot slash Durga, dot slash Durga. Yes, created. Yes, and got the output. Right? Executed, got the output. This exe, this project exe file or Durga exe file contains what? See, at the time of creation of exe file, a GCC means C language compiler. C language compiler creating project exe file. At the time of creating project exe file, here, yes, the GCC compiler, it will take test.to file. Test.to means binary code for your C program. Next, binary code for C library means stdio data setter file. Okay, GCC C language compiler just taking binary code for C program, binary code for C library, and binary code for Linux OS library. By linking all of these, generating exe file. So this project exe, that project exe file. Okay, see C program exe file prepared on Linux OS, then it contains binary code for C program, binary code for C library, binary code for Linux OS library. By linking all of these things, generates exe file. That is exe file. Okay, yes, one more example. One more example. One more example. Suppose C++ program exe file. For example, one more example. C++. C++ program exe file prepared on Windows OS. Windows OS. Windows OS. Windows OS. Then it contains what binary code for C++ program. Binary code for C++ program. Binary code for C++ library plus binary code for yes Windows OS library. Windows OS library. Binary code for Windows. Yes, Windows OS library. Binary code for Windows OS library. That's about exe file. So what is happening here? Exe file. See, exe file is always yes link always links with OS library. OS library. Right? Links with exe file always links with OS library. Okay. So here OS library linking to exe file, right? Okay. At the time of generating exe file itself, it is static linking. It is called a static linking. Okay, see here exe file, yes, linked with OS library, OS library, yes, OS library, OS library at the time of creating exe file, at the time of creating exe file, yes, it is called a static linking. Yes, it is called as static linking, statical linking. Yes, it is called a statical linking. Yes, statical linking. Okay, so exe file statical linking with OS library. Okay, exe file. So exe file. Yes, statically. Yes, linking with linking with OS library. Yes, linking with OS library. OS library. That's it. Here. So here exe file is a statical linking. Java is a dynamical linking. That also will discuss. Dynamical linking also will discuss. Wait. Okay. Now, for example, here test.exe file. Test.exe file. For example, here test.exe file is prepared, prepared on Windows OS. Windows OS. Windows OS. Test.exe file prepared on Windows OS. Then, then, then it links with what? Win library. Windows OS library. Okay. Now test dot, for example, test.exe file prepared in Windows OS here, then it links with Win library. Yes, test.exe file with Win library. How it's working on different platforms? Let us see. Test.exe file with Win library, Win library, working on different platforms, with different operations, different platforms. Let us see. Let us take different platforms here. First, let us take Windows platform. Let us take Windows platform. Windows platform. Okay. Here, this is hardware. This hardware. Okay. On top of hardware, OS is running. Yes. Now, Windows OS. Windows OS. On top of hardware, Windows OS. Yes, Windows with the Win library. Windows OS with Win library. Right? Yes. On top of it, now test.exe file running. On top of OS, every program is running on top of OS, right? OS is a platform. OS is a platform. Okay. So on top of OS, so Windows OS with Win library. On top of this OS, now test.exe file. Test.exe file, right? See test.exe file. How it's working? See test.exe file prepared on Windows OS. Then it links with Windows OS library. So text.exe file with Win library working on different platforms. First on Windows OS. How it's working here? Not test.exe file. When you try to run test.exe file on Windows OS, what happens here? Test.exe file. See test.exe file already linked with Windows library. Test.exe file contains Windows OS library. Test.exe file contains Windows OS library. Since it contains Windows OS library, it will try to call. Yes, it will try to call to Win library. Win library. That's it here. It tried to call Windows library. Okay, the test.exe already linked, right? Test.exe will already linked with Windows OS library. Already linked. At runtime, what happens here? The test.exe file it will try to call Windows OS library. Yes, available. Same library is available here. Using that, it will communicate with hardware components. That's it. Successfully working. Successfully working. Now let us take another platform. Let us take another platform. Suppose Linux platform. Linux platform. Linux. Same test.exe file Linux base here. Same test.exe file on Linux base. Linux base with Linux library. Linux base with Linux library. Right? Now same test.exe file. Yes, when you try to run on this, what happens here? Okay, so same test.exe file, placed on Linux base, here. When you try to run test.exe file, now it will try to call Windows OS library. Reason here, if the test.exe file is already linked with Windows OS library. For example, the test.class file prepared Windows OS that linked with Windows OS library. Test.exe file linked with Windows OS library. Since linked with Windows OS library, when you try to run it here, yes, it will try to call to Windows OS library. Yes, is it available here? It's not available. Not available. Simply fails. So this library test.exe file with Windows OS library that is not matching with current OS. Current OS is different. Library is not matching. Since library is not matching, simply fails here. Yes, it will try to call Windows OS library. It will try to call Windows OS library, but here is not available. OS changed. OS changed. Simply it fails. Yes, let us take one more example. Test.exe file on Unix base, with Unix library, Unix library. Now same test.exe file, when you try to run it here also same thing happens here. Test.exe file, it will try to call Windows OS library, but it's not available. Different libraries are available. It's not matching. Since not matching, simply fails. You try to call it, but not available. It fails. It fails. That's the reason exe file is OS dependent. Okay. See here, exe file. Yes, since exe file. Yes, linked with OS library. OS library. Yes, OS library. OS library. OS library. Yes, it is. Yes, OS dependent or platform dependent. Yes, OS dependent. OS dependent. That's the reason for this. Okay, since exe file linked with OS library, it's OS dependent here. Okay, yes. Now here, why exe file is OS dependent? Yes, for this answer. Reason, yes, exe file contains OS library. Exe file contains OS library. That's it. Simple reason is this is. Yeah, that is about exe. Since exe file contains OS library, it's a OS dependent. Now, same thing. Now let us start Java. How Java made us independent platform. Next about Java. Yes, let us see Java. About Java. Yes, about Java. See Java. For example, yes, same thing in Java. How? What happens? Let us see here. Java program. Yes, Java program. Dot class file. Yesterday discussed about this. After compilation, result is what dot class file. After compilation, result is dot class file. After compilation, result is dot class file. So Java program dot class file prepared on Windows base. Java program dot class file prepared on Windows base. Then it contains, yes, binary code, not binary code. Here it's a byte code. Yes, in Java it's a byte code. Byte code for Java program. Byte code for Java program. Yes, next byte code for byte code. Yes, byte codes. Byte code for, yes, byte code for Java, like a C library. Java there is a library. Java library. So byte code for Java program. Byte code for Java library. Plus binary code for OS library. No, don't contain OS library. Okay, byte code for Java program. Byte code for Java program. Yes, byte code for Java library. See, Java library also developed in Java. C library developed in C language. Python library in Python. Java library in Java here. Java library also developed in Java. So this also Java program. So here bytecode for Java program, bytecode for this Java program. So finally the dot class program is for pure Java program in byte format. Okay. Yes, it's a pure Java program. Dot class file. Yes, it's a pure Java program. Yes, it's a pure Java program, pure Java program in byte format, Yes, bytecode format, right? Okay. Yes. So you don't have. Yes. So you don't have. Yes, you don't have. You don't have any waste library. Don't have any waste library. Any waste library. Okay. Any waste library here. You don't have any waste library here. Okay. So dot class file. See, dot class file, yes, is free. Dot class file is free from OS library. Free from OS library. Free from OS library. So dot class file is free from OS library. Dot class file don't have any OS library. Pure Java program in byte format. Dot class is a free from OS library. Don't have any OS library. Okay. Now, suppose for example here some tested dot class file. Yes, for example tested dot class file. Yes, see tested dot class file. The dot class file may be prepared on any ways. Yes, you don't have any ways label. Okay, tested dot class file prepared on any ways. No ways library. Sorry, let me have some water. Yes, see tested dot class file prepared on any ways. Yes, that don't have any ways library here. Yes, tested dot class file prepared on any ways. Anyways, okay. Yes, you don't have any waste library. Don't have waste library. Anyways, prepared anyways. It's free from waste library. Okay. Now this tested.class file is working on different platforms. Tested.class file is working on different platforms. Just like a C program, this also working on different platforms. Let us see how it works. Different platforms. Okay, tested.class file working on different platforms. How it's working. Okay, let us take different platforms. Yes, different platforms. So tested.class file. Tested.class file. So first of all, Windows OS. So Windows OS with Win library. Okay. Now tested.class file. Yes, tested.class. So tested.class file placing on Windows OS. See this tested.class file. Simply tested.class file just placing on Windows OS. Can I run it directly? This tested.class file, can I run it directly? See, to run this program, what is requirement? Every program has to link with OS library before going to start execution. It has to link. Every program has to link with OS library before going to start execution. It has to link compulsory here. Every program has to link with OS library before going to start execution. Even Java program also has to link, but not linked. How it can run? No, it cannot run here. If this tested.class file is not linked with OS library, then how it can communicate with OS? It has to link. Now this tested.class file has to link with Windows OS library. Otherwise cannot run. Yes, we will link it here. This tested.class file has to link with Windows OS library here. Yes, we will link it here. We will link it here for linking purpose here. Between tested.class file. Yes, between tested.class file. Yes, and Windows OS library. Windows OS, one more layer comes to picture. One more layer. Yes, what is this layer? Anyone can guess it? Yes, one more layer come to picture. Between tested.class file and Windows OS library, one more layer come to picture. What is that layer? Anyone can guess it? Yes, between tested.class file, Windows OS, one more layer come to picture. Okay, one more layer. What is that layer? Yes, anyone can you guess it? Anyone can you guess it? Anyone can you guess it? Yes, patent is JVM. JVM come to the picture. Now JVM come to the picture. JVM means Java Virtual Machine. Sorry. Yes, JVM. JVM come to the picture. JVM come to the picture here. Java Virtual Machine. Java Virtual Machine come to the picture. Java Virtual Machine. Okay. Now what happens here? Now Java Virtual Machine taking your tested.class file. Java Virtual Machine taking tested.class file links with Windows OS library. Once linked here, then communicates with hardware. Then yes, getting result, final results. So this is on Windows OS. Okay, let us take another platform. Another platform. Let us take another platform. Yes, another platform. Another platform. Same test.class file on Unix OS. Unix OS or Linux OS. Linux OS. Linux OS with Linux library. Yes, what happens? Linux OS with Linux library. What happens? Yes, same test.class file. Yes, here Windows OS. Test.class file placing Windows OS. On Windows OS, this is JVM. Here, this JVM taking test.class file links with Windows OS library. Suppose same test.class file placing on same test.class placing on Linux OS. The Linux JVM taking test.class file, taking test.class file links with Linux OS library. Linking with Linux OS library. Yes, let us take another platform, Unix platform. Unix OS. Yes, Unix OS with Unix library. Unix OS with Unix library. Now what happens here? This Unix JVM. On Unix OS, this JVM, that Unix JVM taking tested.class file links with Unix OS library. So once linked here, yes, communicates with hardware. Okay, suppose one more platform, Mac OS. For example, Mac on Mac OS. On Mac OS. Yes, on Mac OS, there is a here of the JVM. Mac OS also contains. Okay, yes. Mac OS also contains JVM. So this JVM taking tested.class file, yes, linking with Mac OS. So what is happening here? What is happening? The dot class file is yes, every time of changing OS, that link is changing, right? Every time of changing OS, every time of changing OS, that link is changing. So it's nothing but dynamic linking. Dynamic linking. See, in case of exe file, what happens here? Once exe file is created, that link is fixed. Now running on Windows space. Same thing running a Linux space fails. Same thing Unix space fails, right? Because there is statical linking. Statical once link that library linked with exe file that is fixed. That link never changes. It is statical linking. Statical that link never changes. It's a statical linking. It's a statical linking. Statical linking, right? Statical linking. Okay. See exe file. See exe file. One second. Let me show that exe file. Yes. See here exe file. Yes, in Linux is a command to check the exe file. Yes, file command checking type of this exe file, type of project. It's a project. It's a executable file. See this ld-linux x86 64.s42 means it's a OS library. .so is the extension for the OS library. If this project exe file is linked with Linux OS library, that exe file. Okay, yes, one more thing. Gedit project exe file. The contents also you can see. Project exe file. Project exe file. Here, just wait a little bit time because of its binary code. See this exe file binary 0s1 format. It's a machine language. This is machine language 0s1 format. This machine language 0s1 format. 0s1 for this is exe file. This is exe file. This is exe file. If that exe file contains what Linux OS library. Yes, already linked with the project exe file. Already linked with the project exe file. Okay, yes, that project exe file, yes, with Linux base library. Yes, library is there here. So exe file contains base library, but dot class file don't have any base library. What happens in case of dot class file? At runtime linking. Yes, if it is running on Windows base, links to Windows base library. Same dot class file running on Linux base, linking to Linux base library. So next Unix, next Mac like this. So every time of changing ways, see every time of, yes, every time of changing ways, right? Every time of changing ways, link changes. Okay, so here what happens here? Yes, Java dot class file, Java dot class file dynamically, dynamically, dynamically means at runtime, dynamically, dynamically, yes, linking to OS library. So Java dot class file dynamically, yes, dynamical linking to OS library, dynamical linking. It's a dynamical linking. Okay, Java dot class file dynamically linking to OS library. Yes, linking dynamically. Dynamically means at runtime. At dynamically means at runtime. So at runtime linking to yes, different applications. Link changes. Link changing means that is called dynamic process. Okay, static means fixed. Static means fixed. Static means fixed. Static means fixed. Dynamic means changes. Dynamic means changing here. Dynamic. Okay, so here Java dot class file. Java dot class file dynamically Java dot class file dynamically linking to OS library. Dynamically linking to OS library here. Okay, yes, since Java dot class file, yes, dynamically, yes, dynamically, yes, linking to OS library, OS library, OS library. Yes, it is an OS dependent here. OS dependent. That's it. OS independent. Sorry, OS. It's an independent platform. It's an independent of platform. Yes, independent. Yes, independent of platform. Independent of platform. Right? It's independent of platform. Independent of platform. Yes. Since dot class file. Since Java dot class file dynamically linking to OS library. It's an independent platform. That is how Java made us independent platform. Just behind this reasons. Okay, so the dot class for linking to OS library dynamically. Who will link it here? JVM. JVM links the Java dot class to current running OS. Okay, so here what happens here? JVM links dot class file to current OS library. That is here. So every time of changing ways that link changes. So every time of changing ways that link changes. Okay, right? Yes, here question is here. Windows based is JVM. Linux based JVM. Yes, next line. Unix based JVM. Mac based JVM. Now question is it part of OS? JVM is it part of OS? Yes, about JVM. JVM is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. JVM is not a part of OS. It's not a part. JVM is not a part of OS. It's not a part of OS. JVM is not a part of OS. Yes, JVM from JDK software. JVM from JDK software. JDK software. JVM is from the JDK software. JVM from JDK software. JVM from the JDK software. Okay. Yes. Once JDK software installed here, yes, the JVM getting automatically. Okay. Yes. So how to get JVM? Yes, to get JVM, to get yes, how to get JVM? To get JVM. Okay. Yes. To get JVM, yes, we have to install. Install. Yes, install JDK software. You have to install JDK software. JDK software on OS. Once JDK software installed, getting JVM automatically. See here JDK software installed. C drive, yes here, program files, Java folder, here JDK software. In JDK software bin, here this is JVM. This is JVM. Here this is JVM. Here this is JVM. So getting JVM automatically like this. So once JDK software installed, you can get it JVM automatically. To get JVM, we have to install JDK software on OS. Okay, JDK software on OS. Okay, 1 second. Hello. అంటే హైర్ చేసుకుంటే వాళ్ళకి ట్రైనింగ్ కాంటాక్ట్ నేను ఒక్కసారి చెప్తాను. సరే 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 ఓకే సరే సరే నేను డిస్కస్ చేస్తాను. సరే to get JVM, yes, you have to install JDK software on OS. Okay, JDK software. Okay, fine. Yes, next one more thing here. One more. See, Java.class file. Java.class file. Yes, is an independent platform. Okay, Java.class file is independent platform, but JVM, yes, is a OS dependent. JVM is a OS dependent. JVM is a OS dependent. JVM is OS dependent. See, it's simple. A surprising thing is Java program is independent of platform, independent of OS, but JVM is a OS dependent. Yes, see that surprising thing. Java.class file is independent of OS, but JVM is a OS dependent. JVM is a OS dependent. JVM is a OS dependent. Yes, why JVM is OS dependent? Why JVM is OS dependent? Reason, yes, JVM is a C++ exe file. JVM is a C++ exe. That's the reason. JVM is a C++ exe file. JVM is exe file. JVM developed in C++. C++ exe file. Yes, if it is exe file, yes, if it is exe file, is OS dependent. Okay, so here, see the Sunsoft, yes, Sunsoft developed, okay, different JVMs for different operations. Yeah, JVM for Windows space, JVM for Linux space, JVM for Unix space. Sunsoft developed different JVMs for different operations. Sunsoft developed different JVMs for different operations. Okay, for every ways separate JVM they have developed. JVM for Windows space, JVM for Unix space, JVM for Linux space, JVM for Mac base, JVM for Solaris. So for every ways separate JVM they have developed. JVM is a OS dependent. Okay, now here JVM makes it Java is independent platform. Yes, I hope you understand, guys, right? Yes, how Java made us independent platform. Behind of this is JVM. JVM makes it Java is independent platform. Yes, since Java.class for dynamically linking with OS library. Okay, it's a independent of OS. JVM links Yes, dot class file to current waste library dynamically here. Since linking dynamically, it's a independent platform. That's here. That's about independent platform concept here. Okay, how Java made us independent platform reasons. exe file is static linking. Since static linking, that is waste dependent. Here it's a dynamic linking. It's a independent platform. Even Python scripting also independent platform. How? Even Python script also dynamically linking to current waste. Dynamic linking. Yes, even Python scripting also same. Dynamic linking to waste library. That's the reason Python is also independent platform. That's it. Okay. Yes. Now, what is exe file? What is dot class? See the differences. Exe file dot class file. See exe file dot class file. Exe file dot class file. See exe file dot class file. Yes, about exe file dot class file. What's the difference? exe file. See exe file dot class file. Exe file dot class file. See first difference. See exe file is a binary code file. Dot class file is a byte code file. Binary code file, byte code file. Okay. Yes, exe is system understandable language. Yes, system understandable language. Dot class versus JVM understandable language. Dot class versus JVM understandable language. Okay, JVM understandable language. So exe for a system understandable language. Dot class versus JVM understandable language. Yes, a byte code file. Exe file is binary code file. Okay, next exe file. It contains program code, software library, voice library. Here this voice library, voice library. Voice library. Yes, what is dot class? Pure Java program. Dot class, pure Java program. It's a pure Java program. Yes, don't have any voice library. Yes, don't have any voice library. Yes, it contains byte code for Java program and byte code for Java library. That's it. Here. Don't have voice library. Yes, exe file is voice library. That's the main difference. Okay. Yes, next. Exe file is prepared file for specific OS. Prepared file, but dot class file is not a prepared file. Dot class file is not a prepared file. Don't have any voice library. It's not a prepared one. Yes, that preparing dynamically. See, voice library dynamically linking with dot class file at runtime here. Yes, here voice library statically linking here. Okay, exe file is already prepared one. Okay, but dot class file is not a prepared one. After moving to OS, JVM prepares as per current OS. Preparing means linking. JVM links to current OS. That's it. Okay. So this is exe file dot class file difference. I think you understand, right? So exe file is a binary code file. Dot class is a byte code file. Exe file linked with OS library. Dot class file is free from OS. Don't have OS. That's the main difference. Exe file with OS library. Dot class file don't have OS library. Next exe file. Statically linking with yes, it's a voice library. Voice library statically linking with exe file. Here voice library statically linking with exe file. Yes, here voice library dynamically linking. That's it. Okay. So exe file is a binary code file. Dot class file is a byte code file. Yes, exe file contains voice library. Dot class file don't have a voice library. Yes, exe file voice library statically linking. Dot class file dynamic linking. That's it. That's the difference. Yes, I hope you understand, guys. I hope you understand, right? Is it clear? How Java program made us independent platform? Yes, why exfl is voice dependent? Exfl is voice dependent reason. Yes, how dot class made us independent platform? I hope you understand, guys. See, generally this kind of topics, no trainer will explain, I'm sure. Okay. Yeah, this kind of topics to explain about this, that guy must have the first of all exfl knowledge. exe file knowledge, that embedded C knowledge, otherwise cannot explain. Even voice knowledge also. Okay, so to understand this topic, yes, last two classes, all the prerequisites explained, right? That's the reason why all that basics explained. Reason is that. So once you understand that basics, voice concept, exe file concept, dot class file concept, interpreter compare, once you understand, you can understand Java features. Okay, so that's about independent of platform. Is it clear? Okay. See, check in Google how Java made us independent of platform. Check in Google. Yes, no one will give the proper information. No website will give the proper information. Yes, why exe file is why is different. Yes, no proper information. Just check for this .exe file and dot class and differences. Check for this. No, you can't see this much of information. Okay. Yes, everything very clearly. My way of explanation is like this one here. Every topic I'll explain like this. That's it. Yes, any doubts, guys? Yes, next topic is installing Java. Yes, tomorrow we are going for Java installation. Tomorrow, Java installation and Eclipse setup. Yes, clear, guys? Any doubts? Hello. Any doubts? Yes, you understanding clearly what I explained today? Yes, what I explained today. Yes, is it clear topic? Today topic that about exe file, about dot class file. Not understanding? See, if not understanding, just you ask me. I'll explain very clearly. Exe file concept, dot class file concept. So this is about independent platform. Yes, watch the recording once again. Once again, watch the recording. Still doubt is there, just you can ask me. Just watch recording once again. Still doubt is there, just you can ask me. Okay? Yeah. Yeah, that's all for today. Yes, tomorrow we are going for Java installation. Tomorrow going for Java installation. Okay? Yeah. So thank you guys. See you tomorrow. Same time, 9:15. Same time, 9:15 tomorrow. Okay? See, Monday to Saturday classes. Okay, Monday to Saturday classes. No holiday on Saturday. Monday to Saturday classes. So thank you guys. Yes, see you tomorrow. Thank you guys. See you tomorrow.